as mentioned, my name is Bryce Adelstein Lelbach. I work at NVIDIA, where I'm the HPC programming models architect. So I'm responsible for the roadmap for our HPC compiler and our core C++ libraries. And I also lead up our standardization efforts around programming models and programming languages. And I'm the chair of the C++ Library Evolution Group. That's my sort of main claim to fame. And I also chair the U.S. Programming Languages Committee. So the C++ Library Evolution Group is the group that is responsible for the design of the C++ standard library. There's two different library groups in the committee. There's the core library group, that are responsible for developing the specification, for proving out the implementability of a design, for sort of making sure that we can actually standardize some design. But the design itself comes from the library evolution group. So when somebody wants to propose adding something to the C++ standard library, they bring it to us. And we evaluate it and review it. And if it makes the cut, then it goes in. This might seem like a sort of basic question, but I think it's actually a much more complex one, which is what is the C++ standard library? So my definition is that the C++ standard library is the home for C++ library facilities that can't possibly live anywhere else. So in my book, there's three different things that meet this category. Things that need language support to be implemented, like type traits, or tuple, or facilities for reflection. Things that encapsulate different platform-specific interfaces, like std thread or std file system, because you want your platform implementer to provide you with those things, right? You want the folks at Microsoft who know where all the secrets of their platform, you want them to provide the implementation of std thread on their platform. And the final thing is what I call vocabulary. And that is facilities that are going to appear regularly in your code and in your interfaces in particular. And so you want a common definition of them. So things like std string view or std span. If every library has their own string view type or their own span type, then if you're using a bunch of different libraries, it's really hard to interoperate with all of them. So it's really valuable for us to have one standard definition. And I think that the standard library today is really sort of at a crossroads. It's unclear what exactly the future direction of the standard library will be. We're tackling a lot of really fundamental questions about the very nature of the C++ standard library right now. And so it's a very exciting time for the standard library. One of the big questions that has been that has come up in recent years is how do we balance velocity and stability in the standard library? The standard library has historically provided very strong long-term stability guarantees. Essentially, we try to never break the standard library ABI. But that is increasingly constraining how we can evolve and improve the standard library and how we can fix problems in it. And so we're trying to figure out, how can we balance between these things? How can we find ways to involve and improve the standard library while maintaining the sort of stability that our users expect? And another thing is that increasingly people want to put things into the C++ standard library, sometimes things that don't fit or that don't belong, or things that can't meet the stability guarantees that the standard library provides. And the reason that people want to put stuff in the C++ standard library is because it's very hard to use external libraries in C++ today. But the standard library isn't a package manager. We really need a C++ package manager. And in fact, we have a number of them. but we really need sort of a standard and common one that can be used across all projects in the same way that CMake has become a standard for build systems. And I think one of the primary goals for C++ in the next decade should be making it like an order of magnitude easier to use third-party libraries in C++. In terms of actual features that we should be working on going forward, I think that over the next decade, there's 4 major focus areas for the standard library that we'll be investing in. The first is asynchrony and parallelism. That's sort of the most immediate thing that we're working on. The first component of that is executors, senders, and receivers, which is our underlying abstraction for asynchrony. Then the next component is sort of tied to that, which is input and output. Pretty much all modern input and output is asynchronous. But the I/O facilities in the standard library are really dated. The I/O streams facility was designed over 20 years ago. It's all based around synchronous input. We don't have any abstractions for doing things like memory mapped I/O or network I/O. And so we need to add all those facilities, but the modern way to do I/O is always asynchronous. So we need those asynchronous abstractions first. And also text processing is, another focus area that sort of ties in with this. The facilities that we have for dealing with text in the standard library are really outdated today. We don't have any sort of real true Unicode processing facilities in the standard library, and it's really important that we have those because we live in an international world. It's not just all ASCII and Latin languages. And then finally, the major language focus in the next decade is going to be around metaprogramming and reflection. And as we develop those language facilities, we will need to build library facilities on top of them that can be used to, utilities for that metaprogramming and for using and manipulating reflection. And we'll also want to look at where in the standard library should we be making use of reflection and new metaprogramming facilities that we get. So that's sort of the high level picture of what we are thinking about in the standard library, like the evolution group today, the sort of roadmap that I think we're looking at, and the sort of problems that we're tackling. So I think let's look at some questions.
Okay. Everyone, if you have any questions, please raise your hand. We will unmute you, and then you can ask your question directly.
It's probably helpful to say how they raise their hands, which is I believe there should be a little face icon in the top right, and you can also do Control-Shift-K and it'll raise it. Or you could physically raise your hand, I guess.
Yeah, I guess that physical raising hand is available only with both of us. I guess perhaps we can relax next time.
Okay, so we have Kashish here. He has some question. Kashish, you can unmute yourself and you can ask your question.
Hi, Bryce.
Hey, how you doing?
Doing good. So my first question is, I know that the libraries, standard libraries are evolving, but I see some libraries like you can say Victor's FMT and Hannah's CRTP. They are, you can say, constantly evolving in, you can say, all areas like compile time, battery, you can say run time, and also you can say better code. So how do you, what is your opinion about that regarding the standard libraries and the, you can say, other individual libraries?
So I would say there's sort of two schools of thought here. And I subscribe to what I'd call the small library, the small standard library school of thought. That is, I believe that we should have a small and focused C++ standard library, and that we should work to enable a rich ecosystem of libraries that are easy for people to use outside of the standard library. And And the other side of that is there are some people that believe in a big C++ standard library, that believe that we should significantly increase the scope of the C++ standard library. And I don't think that's a good idea, because the standard library is actually very inefficient as a mechanism to deploy things. The standard library is not a single code base, but it is a specification that is implemented by multiple different code bases. And so if you were going to go and develop a library like HANA's CRTP, you would write that code once. But if you wanted to standardize it, first of all, there's a huge big time and effort that you'd have to spend to write the specification for it. And then once the specification's in the standard, all of the standard library implementers would have to go and implement it themselves. And usually that means that they each do an independent implementation. And so for something like CRTP, is it really valuable for us to implement the code 3 different times in 3 different ways? In some cases, this is valuable, like the stood thread example I gave before. Microsoft implements it in one way on their platform, and then, Apple implements it a different way in libc++ for their platform, and on Linux platforms, Red Hat implements it in another way in GCC. But for something like CRTP, or even for format, there's less room for differentiation there, yet you're paying a very high cost. And the outcome of that cost is that you can't iterate as quickly. So there's a great benefit to having just a really popular library that's in Boost or in GitHub. And the benefit is you have a single implementation. So it's a lot easier for you to iterate quickly. Also, you can pick more stringent requirements. Nobody is surprised if CRTP or stood format says you must use we support these compilers but not these compilers, or we support these platforms but not these platforms. Whereas when we put something in the C++ standard library, we're really saying it's got to work everywhere, or you can't call yourself a C++ implementation. And again, that slows down the speed at which you can make updates. So while we do want to make it so that the C++ standard library can be more agile so that we can fix our mistakes, the C++ standard library is never going to be able to evolve as fast as the library that you just publish on GitHub.
Okay, thank you.
No problem.
See you later on CppAU.
Yes. All right. Who else has got a question?
Okay. If
Nishank, Dheeraj, you want to please unmute Nishank? He had a question.
Okay. So there is one question from our form which we circulated, and lots of people posted their queries there. So okay, Nishant is here, and
I just unmuted. I just allowed his mic, so Nishant
okay,
can unmute.
Nishant, you can unmute yourself and you can ask your question. Okay, just. Nishant, please unmute yourself. Okay, so maybe he's facing some issues. So Bryce, he added one question in form. I will read out it for you.
Okay.
So what do you think about C++ being largely replaced by Go or Rust over the years? This is a question I also have. Yeah. So what do you think about that?
This is a good question. I'll try to answer it without offending anybody who likes Rust. So if you look at the number of users that Rust has, it's probably like 100,000, or like it could be anywhere between 100,000 and a million. I don't really care. Like order of magnitude, it's 100,000. Maybe it's even less than that. That might be me being generous. C++ has conservatively 5 million users. And it's also got a substantial amount of baggage. And by baggage, I mean both it's been around for a long time, and there's a lot of code that exists that's written in it. When C++ first came out, like at the time, like it was the Rust of its time. You know, it was the cool, sexy language. And over time, C++ had to grow and evolve. And, you know, when any language or any technology evolves, it becomes a little bit, it's like a car, you know, you buy the new car, it's not going to remain new forever. Doesn't mean that there's necessarily anything wrong with it. It just, it accumulates some scrapes and dings over time. And that will eventually happen to any potential C++ successor. I'm not saying that C++ is the best language and it'll never go away. I'm just saying that anything that's going to eventually replace C++ will eventually acquire many warts itself. Now, for Rust in particular, I'll give you an example of this. Rust started off saying that they were not going to have a dynamic library model. They were just essentially going to build everything as static libraries. And they also sort of the nature of their memory safety story leads to a build system story where essentially when you build a Rust project, you sort of build all of your dependencies from source. And you need to be able to do that to do the sort of global analysis of safety that you want to really prove that, hey, everything's okay. And that has, you know, when Rust started, they said, we're going to do this, you know, we know that it has limitations, that's fine, but like we want to be bold and try this thing. And that's worked up until now in Rust's lifespan. And now that Rust is starting to get a lot of serious attention, people are starting to ask, well, like, you know, hey, we really need, you know, some support for dynamic libraries to help us encapsulate code, you know, to deal with not only things like code memory footprint, but also just for encapsulation and deployment purposes, to simplify that and to simplify, you know, updates of binary artifacts. And people are also saying, you know, this whole model where we have to like build the entire world from source as like static objects, as static archives, you know, that's kind of starting to make our builds like pretty slow. Like Rust, it used to be when Rust got started, like, you know, you'd go and do a Rust project and it'd just be really fast to build. But now we've got these really large scale Rust projects, and it's starting to not be as fast to build. And I don't know how Rust will address these challenges. I bet that they'll probably do something cleverer than C++ can do. They'll probably be able to take a more modern approach because Rust is a newer language. And but like the key thing to take away from this is that when Rust started, they said, we're going to do this thing because, you know, we're going to take this approach. We're going to say, we'll just have static libraries and we'll just sort of build the whole world because we think that that's the best way to deliver on what we want, which is memory safety. And now those choices are starting to cause problems, and it's going to be really hard for Rust to navigate a way out of those problems without compromising their core ideals like memory safety. And I think that's just one example, but every language like this is going to run into these sorts of problems. And the measure of the language is how gracefully they address those challenges. The thing that about Rust that is most attractive, actually, I think, is the Rust language evolution process, which is just strictly speaking better than C++'s language evolution process. Rust's evolution process is all done online. They have very modern tooling for it. They have a very clear and straightforward decision-making model. It's a very inclusive model. Essentially, anybody can participate. They're able to deploy changes very quickly. They're able to release very quickly. Their stakeholder model is very robust. I think they've done an excellent job there, and like that's really their strength. And I think if you look at Rust today, and you look at the core language, like yes, that's very nice. But if I think about where it's going to be 10, 20 years from now, I know that it's not going to be as elegant as it is today. I think the real question is, can they keep their evolution process as good as it is? Because the language is going to get more complicated as it grows in scale. There's no way around that, and they're going to have to sacrifice on some of their principles to be able to achieve scale. But the question is, can they keep their process good? Yeah, and I think that's and like if you look at C++ by contrast, like we have a lot of process issues, like the way that the C++ standard is developed, it's not as open as I'd like. We don't iterate as quickly as I'd like. But also, if you look at why we can't iterate as quickly, keep in mind that C++ has multiple implementations, and that's a strength, not a weakness. And we're starting to see Rust move towards a model where it has multiple implementations as well. Recently, there's been a lot of exciting work on adding support for Rust to the GCC compiler. Well, this is going to be a big change for Rust, because previously Rust had one reference implementation. And so sort of, the question of like, is this valid or not was sort of answered by the reference implementation. There was no room for like different implementations to disagree about whether some Rust code was legal or not. Now that they have two implementations, they're going to have a new problem that they didn't previously have. As for Go, I don't know enough about Go to seriously analyze it, other than that people tell me that it doesn't really have a generics or a template system, so it's really hard to write generic code. So, yeah. All right, I think we should move on to another question.
Ravijot, I have enabled your mic. If you want to ask a question. Will we have more standard libraries for AI ML in C++?
Yeah, so I have a good answer to that one. Let me see if I can find the particular slide. All right, here we go. This is a slide from my What Belongs in the C++ Standard Library talk. So as I mentioned before, there is a high cost to putting things in the standard library, because one, we have to develop the specification, that takes a lot of time, and two, it has to be implemented by many different compilers. And there is a long deployment cycle for the standard library, as I discussed, because the scale of the C++ user base is really, really large. It's conservatively, it's around 5 million users. So there's a bunch of different implementations. We have to do a bunch of duplicated work to put something out in the standard library. And it has to work for almost all of our users. It has to work at scale. And that means it takes a long time for us to get changes out. And it means that making changes to what we've shipped is very, very hard. I mentioned before the stability versus velocity debate in C++. There's this rule. Actually, if I search, I'll find it here. There is a law coined by a colleague of mine. It's called Hiram's Law. With a sufficient number of users, it doesn't matter what you promise in your API contracts, all observable behaviors of the system will be depended on by somebody. When you have 5 million C++ developers, everything is going to be depended on by somebody. And so that means that, once you ship something, if you want to change it, you're going to probably break somebody. And you have to think about, you have to do that very carefully. And the end result of this is that it is, once we ship something in C++, it's very hard for us to fix our mistakes. Essentially impossible if it requires an ABI change today. And so because of that, we only want to ship things once they've become established best practice and once the field has stabilized. So we want to avoid premature standardization in evolving fields. If there's substantial active research or the best practices change every few years, then it's not ready for standardization yet. And this is like AI and machine learning is the perfect example of this. There is substantial active ongoing research in machine learning, and every few years for the past couple years, the best practices and the optimal algorithms have changed. So does AI or ML libraries belong in the C++ standard? Perhaps eventually. You'd have to convince me that they fall into one of these three categories. It's not sufficient to me for something to just be useful to be in the standard library, because the standard library has a high cost to put things into it. And so for something to go in the standard library, it needs to really demonstrate to me that it can't possibly live somewhere else. But you could, maybe in the future you could make a case under the portability criterion. And the case that you would make is there's different platforms with different hardware acceleration for AI and machine learning. And so it would be good to have a standard interface for that. And I'll give you an example of something that is similar to AI and machine learning that we are standardizing today. And that is linear algebra. So we're looking at a proposal to standardize linear algebra interfaces. And that is, I think there's many similarities in the story there. There was a time, decades ago, when the best practices in numerical linear algebra evolved as rapidly as they are for AI today. But that time has passed. The basic linear algebra subprograms, the BLAS, which is a separate standard from C++, was standardized in the early 2000s. That has become the widespread standard for linear algebra in the community. It unfortunately doesn't have a C++ interface, which is why we're looking at adding a C++ standard library interface that's basically a wrapper around it. And so that's going to be a good candidate for standardization. And the criterion under which we'll justify its standardization is portability, because every different platform has a different optimized BLAS library, and there's a different way of calling it or using it. And so there is value in us saying, hey, you don't have to figure out how to use your platform's standard BLAS library to do linear algebra. You can just use the standard interface, and your vendor will, hook it up to the optimized version. So will we have a standardized AI or ML library? Maybe. I don't think it'll happen in the next 20 years. But by that time, I think that we will see the stabilization of the techniques in ML to a degree that we could consider standardizing it.
You broke many hearts there.
I know. I'm sorry, but somebody's got to do it.
I guess isn't the same applicable even for the web technologies, etc.? I mean, that's another frequent, I'm sure for you, frequent question. Yeah,
the web technologies is a little bit trickier because there are aspects of web technologies and networking interfaces that are stabilized. The concern there is security. If it takes us a long time to make changes in the standard library, that means that we won't be able to be responsive to addressing security concerns. And so that sets a really high bar for us. And also the standard library vendors, it would present challenges for them to be able to deploy security updates and patches for networking and web components. We deploy security patches and fixes for the C++ standard library today, but the volume of fixes is already pretty great. But the attack surface area that we'd have to worry about would be much greater if we had HTML, an HTML server library, or HTML parsing and rendering, etc. Even something like Unicode is going to be challenging because the Unicode tables update more frequently than the C++ standard does. And one of the reasons why the standard library is challenging to update is because it is something that is linked by default with everybody's program. And so while most libraries are opt-in, the standard library is opt-out. If you just compile a C++ program by default, you get the C++ standard library. Some vendors have started moving away from that model. So with some compilers, I believe with MSVC, and I know for certain with libc++, maybe even with libstdc++, if you want to use the file system library, you have to add a separate link command to that. And one of the reasons for that is to make it so that they can update those libraries quicker. Because if it's a library that's linked into a certain program by default, then shipping updates to it is challenging. As anybody who's ever had to update their libc on like a Debian system knows, sometimes you go and you have one package that needs to update it, and then you end up having to update like your entire system.
Okay, so Bryce, here I have one question. Means nowadays there is one term WebAssembly that is very new and coming very fast. So and in that C++ is very much preferred. So what you will say means, can I say that maybe one more field for C++ developers to explore web tech things and all those?
Yes, well, actually, it's very interesting. One of my best friends, JF Bastian, who also happens to be the chair of the C++ Language Evolution Committee, my counterpart, he was the chair of the WebAssembly group, and they just won a SIGPlan award for WebAssembly. So yeah, WebAssembly is actually a really interesting C++ target because it may succeed where the JVM and Java failed to succeed, in that it is this sandboxed environment that you can compile C++ to, or essentially anything else. And it can run pretty much anywhere because it can run in, it runs in a browser, and browsers are everywhere. And it's pretty fast. So obviously its main use case is for, a lot of browser-based technologies, but I wouldn't be surprised if we start seeing more projects using it as sort of like a, either for portability, to have like a portable execution environment across a wide range of hardware, even more portability than what you get with C++ today, or more importantly, for security. WebAssembly is a really good way to run untrusted code on a platform. So yeah, I mean, I think that the future is bright for WebAssembly, and I imagine that that it and C++ have a harmonious future.
Yeah, thanks for this explanation. And now, Samir, if I'm enabling you, you can unmute yourself and ask your question. Samir Kotasthani. Samir, are you there?
Hello.
Yes, Samir. Good to hear you.
Hey, hello, Bryce. So,
Hey.
two questions, quick questions. So, regarding this WebAssembly, do you think that it will replace JavaScript? And secondly, what do we have any alternatives to mscripton? So this is my first question, and second question quickly was regarding standard package manager. So what are our difficulties having a standard?
All right, let me tackle the WebAssembly question first. So will it replace JavaScript? No, but I think that's because they're at different levels of the stack. So JavaScript is, JavaScript is a high-level language that runs anywhere. That's how I like to think of JavaScript. WebAssembly is not a high-level language. It's a portable like execution target. So in some ways, maybe I would think of it as like WebAssembly is like the assembly instructions for the platform that JavaScript runs on, which is the browser. So WebAssembly is useful useful primarily as a target for generated code. So it's not something that you would code to by hand. It's something that you would take some language like C++ and generate code for, or you'd have some other, mechanism of generating WebAssembly. Either from some language or from some particular like code generator that's specific to your project, etc. I'm not knowledgeable enough about web technologies to fully answer the inscripting question, but my understanding is that WebAssembly is a technology that is more or less aimed to replace things like inscripting and NACL and like other things like that. It's supposed to be like a better way of going from C++ to something that runs in your browser. Better and safer way too. Your second question was about package management. So having a standard package manager is going to be challenging for a lot of the reasons why, like, C++ isn't a language that just has one compiler implementation. It's a specification. And so having like a centralized service for package management would be tricky because it would limit implementation options. And it would be really hard to build something that would service all of our users, and something that like all of our users would get behind. So I think it like having just one of a thing is not the C++ way. But instead, what I imagine is that we would want to work to enable the diversity of package managers that exist. Like, there are package managers today. The two that have the largest market share that are C++ specific dependency managers are VCpackage and Conan.io. They have an order of magnitude more market share. My rough estimate based on a number of different metrics I've looked at. I haven't actually like run the numbers, but you look at their traffic, the number of packages they have, their traffic, number of GitHub stars they have. It's pretty clear that those two are out ahead of everybody else. So maybe we'll end up consolidating around just two. But interestingly, VCpackage and Conan.io have fairly different models on the back end for how they manage artifacts. And I think that there's a lot of room for diversity in like the actual management of code artifacts and publishing. And I think it's good for C++ for that diversity to exist. And like I think it's good for like companies and products that care about C++ to have multiple different options for how they're going to deploy their packages in the field. But what we want is we want to separate out what is the system that I'm using for my for package deployment and for like storage of my artifacts, etc. We want to separate that out from the question of how do I express my dependencies and how to package my thing in a standard way. So here, I'll show you guys a couple slides I got on this. So if you look at like the ecosystem today, each C++ project will have some build system. And then if you want to support all the various different package managers today, you'd have to have some package description for each one of those package managers. And, if you wanted to support using any package manager, like expressing your dependencies with any package manager, like that's not covered by this graphic because that'd be even more complicated. You'd have to write, you'd have to write, an expression of your dependencies and probably a build system separately for each one of those different package management systems. But let's face reality, CMake is sort of the de facto C++ build system. And if you don't believe me, here's CMake's market share over the years. CMake, this is according to JetBrains' developer surveys. CMake's market share has consistently risen over the past 4 years. It's now at over 50% market share. So yeah, it's not specified in the C++ standard that you have to use CMake, but there's a pretty clear trend here. And it's better for us to just standardize around something than for us all to have our own build system mechanism. So we should all use CMake, even if CMake's not the best thing. It's made the best thing by the fact that everybody uses it. So, okay, so let's just assume that everybody's build system is written in CMake. And that actually makes life a little bit easier for this package story, because that means that there's only going to be one way that you will write and express your build, and that you will write and express your dependencies. So now we have a standard way of you saying, hey, I depend on these packages, and a standard way of saying, here's how you build my thing. Now, all that we really need to get is this thing right here, which is a standard package description format that all of the different package managers can consume. This is actually a really challenging problem, and people who work on the package managers tell me that they don't know whether this is possible. But I should say that a lot of people that I work with, when I first tell them about my crazy ideas, they tell me it's not possible. And then over some period of years, I wear them down. So who knows? Maybe it is possible. But if we had some standard package description format that all the package managers can consume, then you could just write that package description format once, or even better, CMake could just know how to generate it. And then you would essentially only have to do things once. You'd write your build system, you'd say, here's what my dependencies are, and then you'd somehow say, here's how you package me up, and send me out to whatever different things I want to be published on. And then you could choose, I only want to publish it on VC package, or, if you wanted to, you could go publish it on all these other things because they'd all be supported. Now, there's one other component that we might need, and that is some way of avoiding name and version conflicts. I don't know how many folks here have spent a lot of time dealing with both Debian and Red Hat systems, but one thing that is super annoying is that if I go to install GCC on a Red Hat system and on a GCC system, the packages have different package names. And every time I have to go look up what's the name of the GCC package that will install me G++ on Red Hat. And, it's the same thing for libraries like Boost. And the problem actually gets worse with versioning, because how is the package going to be versioned in the Debian system? Well, usually the Debian system will pick some Debian specific versioning, and then they'll stick the actual version of the package at the end there. And so it can be really challenging for you to say hey, I don't care what environment you're on, please just install me Boost 1.8.5. Spelling that out can be really challenging. So it might be useful for us to have a central registry where you can register a package name, the versions for that package, and maybe some other metadata. Maybe even the entire standard package description would be there. But the other metadata that you might care about is what C++ modules does the package support? What are the names of those modules? And the idea would be that anybody could register stuff in the registry. And because the registry would not store code artifacts, the registry would be fairly cheap to run, and there would not be the same level of concerns about like code ownership that you would have with a full-fledged standard C++ package manager, because this would just be a registry with just like package names. Now, if your company has some super secret package name, maybe you wouldn't want to register it. But there's a big difference between saying, hey, I'm going to publish my libraries and my apps with this standard C++ package service. I'm going to actually give them my code artifacts and put them on their service. That's a much bigger ask than saying, hey, I'll just register the name of my thing in this registry. And then, the registry could be used however the package management systems could choose to just ignore it. But the idea would be that it would be a common resource where you could go to make sure, hey, this is how this package wants to be named. And also like, oh, hey, somebody else has already got a package with this name. So that's sort of my rough ideas on what we could do to start enabling package managers better in C++. And that's specifically what I want to do. Is I don't want to necessarily standardize a C++ package manager. There already are C++ package managers. I want to standardize how you interact with them, and I want to make it easier to use them.
Yeah, that's pretty.
Ooh, I see. Sorry, go ahead.
Yeah. So Nisank Patil, if you have any question, you can unmute and you can ask your question, please. Okay, so
I see a good one. I see a good one in the chat too.
Yes, so I think we can take that. So I hope you already read that. When networking TS will be part of standard libraries.
So I would say that's the wrong question. The question is, will the networking TS be part of the C++ standard library? I know I'm not the most, perhaps it's not the most inspiring talk, but I got to be honest with you guys. And girls. I shouldn't just say guys, but I got to be honest with you folks. The networking TS is based on BoostAsio, which is a very popular library. I used BoostAsio a lot. My old job, the runtime I worked on, HPX, it was a parallel HPC runtime. Its networking layer was based on top of ASIO. So I'm very familiar with ASIO. I think it's very, very, very elegant design. But there's a few challenges here. First of all, ASIO was designed in a pre-C++ 11 era. And that would not have been as fatal now in C++ 21 and 2021 as it would have been like 5 or 6 years ago. So it was 5 or 6 years ago, the best practices on library design would not have been as different as they are now. Like pre-C++ 11 still would have been like a big lift, but it's an even bigger lift today. The best practices have evolved a lot. There's a lot in the networking TS that relates to the management of object lifetimes. And it is not clear whether that reflects sort of our existing best practices. It was not really designed around move semantics because those didn't really exist at the time. And it's not clear how we would design the library differently today with the existence of move semantics and with the existence and support for returning things like non-movable, non-constructible types. Also, the networking TS relies pretty heavily on a number of type erased facilities, and I am absolutely terrified anytime we want to introduce anything type erased to the C++ standard library, because most things in the C++ standard library, you can't change the existing thing. Like, you can't go and add a data member to std vector because that would change the ABI, and that would be an ABI break, and that would be bad. So normally changing existing things, breaking change, but normally it's fine to make additive changes. Adding a member function to std vector, that's fine. polymorphism essentially makes it impossible to add new things. You cannot add a new virtual member function to a polymorphic class without breaking the ABI because it changes the layout of the virtual table. This essentially means that when you standardize something with a virtual table in C++, that is set in stone forever. The best example of this is I/O streams. A couple years ago, I wrote a proposal that pointed out the fact that you could not do std_cout left shift of a volatile qualified pointer. And like, this is like a very simple thing. Like for some reason, I had a volatile pointer to something and I just wanted to point out the printer address and it did not work. I would have to cast it to be a non-volatile pointer. So I said, okay, this is a very simple fix. We should add support for this. But it would have been an ABI break to add this thing because it would have required adding a new virtual member function to one of the IO stream base classes. And we couldn't do that. So anytime there's a proposal that heavily relies on type erasure, I'm very, very, very skeptical of that proposal. And usually what I'd like to see is like a proposal where there's a non-type erased version, and then later, if we determine that we need the type erasing thing, we add the type erased thing. There are some other challenges with the networking TS. The async model is not aligned with the general async model that we're pursuing for C++, executors and senders and receivers. And it's not clear if that's something that we're okay with. And it's also just like a really big thing. Like it's 450 pages. We know that we need to modernize it, and that means that we'd have to do a full review of it. And it is not easy for us to get the institutional knowledge to be able to effectively review the networking TS. Like I am responsible for the C++ library design team, and I can tell you that like the times that we've looked at the proposal in the past, we have simply not had enough of an understanding of it to be able to effectively review it. And because it's so large, it'll be very hard for us to build up that understanding. Finally, there is the security problem. The networking TS today contains, it's primarily an abstraction around a sockets layer. And it's an abstraction around non-secure sockets, just your typical Berkeley sockets. A number of different key C++ stakeholders have raised objections to a networking facility that does not use secure sockets by default. And some of the champions of the networking TS are opposed to doing that. And because this is a security-related concern, it's not something that people take lightly. It's a very big deal for somebody to say that they would vote no on the C++ standard. Almost never does anybody say that, but there are multiple stakeholders that they're either in a field where their domain is explicitly security, or they're somebody like Apple that owns a platform. Not that Apple's one of those people. I was just using him as an example, where they care about the security on that platform. And the idea of introducing a C++ library facility that they perceive as having security holes large enough that you drive a Star Destroyer through them. In particular, the worry that, people will go write code using the default thing, which is non-secure sockets, and then that's going to be bad if they put that in production. That is enough that I do not think that the current proposal, without addressing that question, would be able to get voted into the standard, because I think there's enough people who would say we will disagree with a C++ standard that has this. So at the minimum, for the networking TS to get into C++, it would have to overcome that challenge first, because it would require a huge amount of effort for us to review and revitalize the networking TS. And library evolution cannot make that effort until we know that the security question has been resolved, because if we invest that effort and then we figure out that we're not going to be able to resolve the security question, then there was no point in us doing that. Short version of my answer, it is right now, it is middle of 2021. The design freeze for C++ 23 is February of 2022. I don't think I've publicly said this yet, but I am 100% confident that networking will not go into C++ 23. It has missed the window at this point. To make it into 23, it would have to have been voted in February 2022. That's just not going to happen. Maybe if the pandemic hadn't happened, this would be a little bit different. But honestly, I do not think that this would have changed. I don't think that the pandemic was responsible for networking not getting into C++ 23. I think it's just a reality of the complexity of the problem here. All right. I'm sorry. I'm just giving you guys all the depressing answers.
And executors? No hope, right?
I think it is. I am more confident now about executors than I've been at any point in the past 4 years. And a couple of months ago, I said I was more confident about executors than any point in time I've been in the last 2 years, but now 4 years. I'm feeling very good about executors right now. There's a new leaner proposal that was just released. We're going to be reviewing it next Tuesday for the first time in a joint session of library evolution in the concurrency group. I've been telling people like privately that I feel like it's like 70% chance. I think it might actually be higher than that. I think it's pretty likely that we're going to land executors for C++ 23. If we don't land executors for C++ 23, I'm almost certain we'll publish an executor's technical specification by the end of 2022. Yeah, so there's some good news. Executors, some good news. Yeah, and I do think that it's a really good proposal. And the latest proposal is actually pretty nice to read. It's a simple number. It's P2300. I put a link to it in the chat.
Yeah. So there is another question from Satish. What is your view on the ABI stability of C++ libraries and why it is important?
Yeah. So I gave a C++ Now keynote that covered this in some detail. But the question, why is it important, is what I'm going to focus on here, and I think it's a really good one. There is here. Let me see if I can find a slide on this. So yeah, here, that's what I wanted. Let me share my screen here. So there's two different notions that you got to think about when you think about compatibility. The first is, and I'm going to give definitions that are specific to C++ and the standard library here. The first is backward compatibility. That's when you want to mix newer code with or code built with an older compiler can be combined or used in a newer build. And forward compatibility is when you have code built with an older compiler or language dialect that can be used with newer code that was built with a newer compiler. Does that make sense? All right. So the forwards compatibility use case is the ABI use case. And the challenge there is when you're dealing with dependencies. So this is the forwards. So here's the backwards compatibility use case here on the left. This is where I've got code that was written with some older dialect, and I have chosen to compile it with a newer dialect. And this one is an easier hole to dig ourselves out of. If something breaks here, we can simply say we will go back to using the older C++ language dialect, right? If this breaks, I can just say, okay, I will roll back to using C++11 here, C++11 here. The challenge with forward compatibility is I've got some code of mine that's compiled with some newer C++ dialect, and I'm using some set of libraries. And one of those libraries that I'm using, I don't have control over it. Somebody else built it. Maybe it's a system library. Maybe it was, provided to me by some customer or some vendor. Maybe I don't even have the source code for it. Maybe it's just a binary blob. And it was built with an older compiler and an older language dialect. And I want to use some newer compiler and newer language dialect and link with it. And there is no solution for me other than to roll back my code if that external thing is broken. And usually the surface area of exposure for forward compatibility is much larger than the surface area of exposure for backwards compatibility, because backwards compatibility is explicitly about taking code that was written a long time ago. So I have access to the source code and I want to build it with a new version. Whereas forwards compatibility might involve dealing with binary artifacts. The other reason, and I'm not going to get into the slides for this because there's a a good chunk of my C++ Now keynote goes into this in great detail, but nobody understands what ABI is, and nobody really understands the surface areas of all the ways that it breaks, and nobody really understands all of the different ways that can manifest in your code, but when you break ABI, it's not typically something that you catch at compile time. It's usually something where some bad things happens at runtime, and usually that bad thing is oh, this one library thought that this thing was a 24-byte struct, and this other library thought it was a 16-byte struct, and just wrote everything in the wrong place. And it's very challenging to diagnose and debug those problems. And that's why ABI stability is so much of a concern. API stability is important, but we all agree that that's important and we break it less frequently. And honestly, if we do break API stability, that means your code stops compiling, right? And it's so much better for your code to stop compiling than for your code to compile and then blow up at runtime, which is what happens often when ABI stability gets broken. The classic example of this is when std string was required. Essentially in C++11, we forbid copy on write string implementations. And that required libstd C++ to take an ABI break to their std string implementation. And std string appears everywhere in everybody's interfaces. And this has been called the $1 billion mistake by some people. It's probably an accurate assessment. It is a hole that GCC is still digging themselves out of. It was so painful that if you ask the GCC maintainers, the libstd C++ maintainers, when they would like to next take an ABI break, they'll tell you never. This was a miserable thing for a decade, and it still breaks people's code today. So that's why ABI stability is important. If you want to learn more, watch my talk, the video of which just recently came out.
Yes. So Bryce, there is one question someone asked from in our someone filled in the form. It's very good, I think, for people who are new students who are learning. So the question is if I am well familiar with C++11, what would you suggest to learn in C++17 or any new features? What are some main features that we should know or care about 17 or 20 something?
Well, I definitely think that concepts is probably one of the more important ones in C++20. It definitely changes how we write code, and it does it in ways that are more natural than I would have thought. In particular, there's this thing called abbreviated template syntax, where essentially you can have templates without actually having the template keyword, just by having something like just as you do with lambdas, by just having parameters that have auto. So instead of a type, you just put auto, or you can put auto and then the name of a concept. And there was one camp of the committee, a conservative camp of the committee, that was sort of opposed to this because we were worried that that it would make it too unclear which things are templates and which things are not. Although admittedly the original syntax was more complicated, or the original syntax did not require the auto keyword, so it was harder to tell. And I was one of the people that was sort of opposed to abbreviated syntax, but I accepted the compromise because I was like, I won't use it, but it'll be nice to have. But I have to say, I have used abbreviated, template syntax. It is very nice. I will continue using it. It makes my code examples of my slides a lot cleaner. And so I really do think that concepts really will change a lot of how we write code. And it makes how we write generic functions so much more meaningful. There are a lot of benefits to concept, or there's a lot of purported benefits to concepts around like the actual checking and the constraints. And they were supposed to give us better diagnostics. It's not clear whether they do. The compile time performance benefits, not, there's some cases where it makes it slower, some cases where it makes it faster. It is functionally useful as a replacement to Sphene, but I don't actually think any of that's why you should learn concepts. I think the main reason to learn concepts is that it is, like, aside from any semantic code effects, if I'm writing a function and that function takes a generic parameter, anything that can be an integral, like, it is just more natural and expressive and better in the code for me to say this thing is an integral. It's just like better documentation. And the fact that you also get all those secondary benefits is great too. But like, I think that's the main reason to do it, is because then you start thinking about, hey, this function doesn't just take a template that's anything. Like, what type of thing does this take? Well, maybe it takes something that's swappable, or it takes something that's integral, or it takes something that's pointer-like. And then you start thinking about what are the different kinds of things that I take in my interfaces. And then you start thinking about, how do I describe those things? And then that makes it a lot clearer to users of your interfaces what the contracts are. Other things that are important. Well, I think coroutines is something that everybody should start learning, because they will almost certainly be the basis of all of the asynchronous library interfaces that are coming. I said before, I think, my list of priorities for the standard library in the next decade, the first one was asynchrony. And I essentially think everything that was in that list will end up being some form of asynchrony. The input-output will be asynchronous. The text processing, not so much, but it's processing text that came from some input or output source, so that it came from somewhere that was probably asynchronous. And so I think it's really important to learn coroutines, because they are the interface that will be exposed. So executors and senders, receivers will be under the hood, but the natural way for users to write asynchronous code will be through coroutines. Ranges are also fairly important to learn and understand from C++20. There's a few other minor things. Well, there's a few other features that are not as major as those. There's something called Ctad, class template argument deduction, which I am a very big fan of. There are some people that don't like it as much as I do, but I think it's just great. If const expr from C++17, and just in general, all of the const expr improvements over the past decade. Like, const expr has been like a sleeper feature, because we introduced it in C++11, but the const expr in C++11 and the const expr in C++20 are two entirely different beasts. In C++20, you can have a const expr stood vector. In C++11, you could not have a const expr function that had any statement other than a return statement. So const expr has changed a lot, and it's really important to understand all the ways in which you can use const expr today, because it's a really powerful tool, and it's how you should be writing metaprogramming code instead of doing typed-based metaprogramming. So I think those are the things that I would say. Oh, and I would not worry about learning modules for another like year or 2 or 3 because there are not enough modules implementations or enough modular libraries for it to be a relevant skill yet. So I just like don't worry about modules. They're coming, like they're in the standard, but it's something that will take a longer time to get deployed.
So in continuation to this, and I think this will be our last question for today because we already took a lot of time from you. This question is from Nisang. So he want to understand means what do you think some good projects you can suggest for a beginner open source project that someone can start contributing into that if you have any suggestions?
Well, I'll say my first one, but I'll say it with perhaps a little bit of bias. But contributing to a C++ standard library is, I think, a really good way to get visibility and to like build up a track record for yourself. Like if you want to get hired, contributing some patches to a standard library is a pretty good way to go. And you'll learn a lot in doing so. In particular, you'll learn a lot about deployment at scale because standard libraries have a very wide deployment. And so it's not going to be something where you're going to send a PR and the PR is going to get like accepted the next day. It's going to be something that is going to take time. There's going to be multiple reviews. You're going to get asked to do a lot of weird things that you might not have thought about. You're going to spend a lot of time writing tests. You're going to spend more time writing tests than you might think is reasonable. But if you want to be in C, like a C++ programmer, writing sort of core software, which is what C++ programmers do, that's a good way to get started. I'd say some other good projects, general purpose libraries like Boost are always a good place. Something like Format, CRTP. There's a really good JSON library called Nahlo-Holman ::JSON. There's another cool project I work on called Inja. Generally my advice is it's much better when you're getting started to have a mix of contributions to open source projects and your own projects. Don't solely focus on doing your own projects. You might strike gold on a few things. But if you end up with a portfolio that's really just, a bunch of projects that you've done that nobody else is using, then you haven't gotten any experience with deployment. I like to say there's 3 different types of field experience: implementation experience, usage experience, and deployment experience. If you just write something yourself, you have implementation experience. When people start using it, then you have usage experience. When people have used it for a long enough time that you have to manage how you make changes to it, then you have deployment experience. On the other hand, you don't want to solely be making contributions to other people's projects, because if you've only made like patches to other people's projects, you've never had the experience of setting up a project yourself from scratch. And you've also never had that like creative freedom of thinking about how you would structure things. And you really want to have that to know in the future when you're, a senior seasoned programmer, you want to have that experience there. So you really want to have a mix of both. So I would say, if you're like spend half your time working on contributions to upstream things and spend half your time working on projects of your own. And when you're doing projects of your own, don't go for like large quantities of them. Like make a thing and make it good and make it in a way where people will use it. Because they're like building up users, it'll teach you a lot about the project and about like projects in general. Yeah. I think I could probably do 1 or 2 more. If you guys don't have a hard stop, I'm good for 1 or 2 more.
Yes. Okay, then we have lots of questions.
Okay.
So Kashish has some question. Okay, Kashish, I'm enabling your mic. Please unmute and ask your question. Kashish?
Hello, are you getting my voice?
Yep, we are.
Yes.
Okay. So Herb says that he wants C++ to less complexity, and you can say in Bjarne's original view, he says that in C+20 or C+23, he will have, you can say, his initial view complete. So what is your view, or you can say your goals that you have in, you can say, previous year of C++?
I think that Herb and Bjarne are far too concerned with this. I do not believe that we can make C++ simpler by adding more things to it. It just adds a different type of complexity. I am far more interested in managing complexity and in managing change over time. And I think that there may be a difference in like our perspectives. Like I fundamentally consider myself a software engineer, not a computer programmer. And I am very much of the school of thought of Titus Winters, who is also somebody that is first and foremost a software engineer, not a computer programmer. So I like and appreciate elegant and simple things, but I also like internally recognize that the world is not that way. So searching for simplicity just for simplicity's sake, I don't know that that necessarily has value. And while there are ways in which we can make the language simpler, almost every time that we've tried one of those things, it has resulted in additional complexity, like initializers lists, and just like everything we've ever done to initialization in C++ has in some ways come back to bite us. So I think we have to be like cautious and measured here. I think that, yeah, reducing complexity should be one of our goals, but I do not think that I value it with as high a priority as Herb or Bjarne do. But I think part of that is that I think Bjarne thinks a lot more about the new programmer than I do, and like I'll freely admit that is a weakness of mine. But like I am not primarily focused on the new programmer. Because I don't think that C++ is a language that's necessarily for the new programmer. Not that that means that new programmers shouldn't use it, but it is a language that is used to write, sort of core, important, critical software. So the key thing for me is, can it do that? Can it do that safely? Can it do that effectively? Can it do that efficiently? And if it's a language that's a little bit harder to learn as a result of that, I'm not necessarily opposed to that.
Okay, so what is your, you can say, view, or you can say final view that you have when you joined the standard library? Like Bjarne said, he will have the complete library in C+23. That was his initial view in 1998.
Oh, yeah, I don't think we'll ever be done. I mean, maybe by the time I retire. Yeah, I think the C++ might be done by the time I retire. I got like another good 30 years. So I think that C++ will probably be approaching the end of its lifespan as a primary language by that point in time. I could be wrong. It could be that C++ just keeps on going. Like Fortran has recently sort of come back and been revitalized. So yeah, maybe I am wrong. Maybe I am wrong about that. And maybe 30 years from now, C++ will be like Fortran and we'll be having another resurgence. So who knows?
I guess it is 30 years from now for them.
Yeah.
At this
yeah.
time. And they are not done right.
Yeah.
Right? So
yeah.
Okay, so Nikunj has a question, and he want to know when can we expect NVCC to support core C++ language features like exception handling and error codes.
Oh, you mean exception handling in device code? That is some exception handling on GPUs is on like a list of things that we'll get to that like that we want to do just for like completeness. If you mean like when will the CUDA runtime and driver APIs have a C++, wrappers for them? Yeah, they're pretty difficult to work with, and the error handling model is not super pleasant for CUDA today. We are starting to introduce CUDA API wrappers in our core CUDA C++ library, libcu++. But like that's going to be an incremental thing that'll take time. Yeah, and I should note that NVCC is not the NVIDIA compiler that I am a representative of. I represent the other one, which is NVC++, which is our HPC focused compiler. Yeah.
Okay, so the next question is from Ankur. Ankur, you can read out your question.
well, I was waiting for an opportunity to ask. I put a comment here or there, but I thought I'll also put mine on the chat. But yeah, I saw you recently also authored a proposal on exceptions. It was with 8 other people. I have not gone through it totally, but I guess it's getting leaner, thinner, and there have been some thoughts about making it usable and more applicable even in the constrained environment. Is it coming?
Yeah, so I'm not sure if I'm actually an author in that proposal. I could be. People put my name on stuff all the time, but I'd say 2 things. One, I would say exceptions actually do continually get cheaper with time, just as polymorphism gets cheaper with time because processors get faster and compilers get better. In terms of what I think you mean is Herb's deterministic exception handling proposal, I think it's very promising. There are a lot of bold proposals that come through the committee, and I usually have a more conservative and reserved viewpoint of them. But the deterministic exception handling proposal is one that I actually I have not looked at it and been like immediate thumbs down. So I kind of like it. Now stood expected is going into C++ 23. I can't recall if we voted it in yet, but that's something that's like I'm confident enough that it will make it in that I will just say it's in C++ 23 now. And I think that will probably get a lot of usage. Like that is the model that I'm advocating for a lot of folks to use. The other model that I really like is the stood file system model, where you have an error code parameter that takes something by reference, and the default parameter is this special object that's called throws, and internally it checks whether the object is called throws, and if it is, then it throws, and otherwise it sets the error into the error code object. So those are that's the 2 models that I kind of like. I do think that there are some environments where just like exceptions are like the right thing to do. The big problem, of course, is like those embedded environments. I think the best thing that we could do for the embedded environments would be to just recognize, to not have the default world be a world where you can recover from out of memory errors. If we didn't have that, if by default allocation did not throw, if it was non-recoverable, then pretty much it would solve most or all of the problems that that folks have in the standard library. But really, like I would, my preference would be in a lot of places to sort of design around this, to allow there to be an API that throws an exception for the people who want to use it, but then provide some other API that you can use in environments where you don't want the exception, where you can't handle exceptions, which gives you back an expected or does something else. I do think that this is one problem that the committee will solve in the next 10 years. It's not on my list of priorities. Maybe it should be. But yeah, that's a good one, and I do think it's one of our bigger challenges. Yeah.
And about the second option which you told about, like there's an implicit throws object.
Yeah.
Isn't that a future ABI problem?
No, but it's just like it's a special placeholder tag. So essentially the idea, like the other way to think about it is that there's two overloads of the function. There's one overload of the function that doesn't take an error code and that one throws. And then there's another one that takes an error code. And if you call the one that takes the error code, then it doesn't throw and it sets the error code to whatever the error value was. And like I kind of like that API. It does a lot of what I'm looking for in an API. I don't know how we would design an API like that better with something like a stood expected, but it's interesting. We just standardized stood expected, but I honestly could not tell you how we should use it in the standard library. And I suspect that it will be a while before, I suspect that a bunch of people will try to use it in the standard library in proposals, and there will be a period of time where the committee will be like, we don't know how to use this, so nobody uses it in the standard library at first. And then over time, we'll find a way to use it. Yeah. I really do think that the expected approach is like kind of the way to go. Yeah, there are still some cases where like exception handling is nice. Yeah, I wonder how much synchronous error handling really will matter going forward, because I think so much of the way that we write code is going to be asynchronous in the future that that may be the real thing we have to think about.
Yeah, Samir, you have raised your hand. So if you have any question, you
yes,
please.
Yes. Am I audible?
Yes,
yeah.
Yes, you are.
Yeah. Hey, hi, Bryce again. So
hey.
A simple question, but probably with a difficult answer, maybe. So the question is, what are your tips on how to keep up with C++?
How to keep up with C++? So I think that attending C++ conferences is probably the best way to keep up with the latest trends. Unfortunately, you don't have a ton of options in your chunk of the world. In the US, I can get on a plane for 2 hours and go to a bunch of the big C++ conferences, but the videos are all like really good quality, and a lot of people like that. I personally, I'm not somebody that really learns well through videos, or like I've never really watched a programming video. I don't really read like a programming book. I'm like somebody that like I won't understand it until like I go and like do it myself or like write examples. So that's always been how I've learned. So like in some sense, like for me, the best way to keep up with C++ was to join the committee, because I learned through doing. We used to do these regularly when the committee met face to face. We didn't do them during the pandemic, but I imagine we'll resume them, where after every committee meeting, we would post a Reddit thread with a detailed summary of what happened at that committee meeting. And those are a really good way to keep up with what's going on. Like we sort of have the history of them like going back in time. So yeah, I think like that's a good thing to like watch if you want to like get your pulse on what's like, that's a good like concise way of like figuring out what's going on with the committee. Reading through the like committee papers is, not a bad idea too. There are a lot of them, but usually you can just like skim and see which ones sound like the most interesting ones. But honestly, like I think that the conferences or like meetups, are probably the best way. Honestly, like, yeah, you don't need to have a local conference. If you have a local meetup, then you'll be able to stay up to date, because there will be somebody at your, your meetup group that'll have gone to the conference. Like maybe not everybody here will have gone to, every C++ conference, but probably some of you will have been to each one. And the virtual conferences are a really, really good option too. And they usually are pretty cheap to attend. And hopefully you can get your employer to pay to let you attend some of these things.
Yeah.
And
So
like, don't be afraid to ask your employer. Like, you can ask them. The worst thing they can do is say no.
Yeah. It worked for me once in 3 or 4 years.
Yeah.
That much persuasion was needed.
And because we don't had any such C++ community in India, so I'm very happy that people are interested and very surprised that no one took this initiative and started a community like this in past so many years. Means Ankur, I will also blame you.
Yeah.
No, that's not right. There are 2 already put up on the ISO site also before us from India, one in Bangalore, one in Pune, where we both are. But they didn't take off. The one in Pune was called as Boost and Modern C++ Meetup, and perhaps they met 3 times.
Well, and I mean, I would actually say that y'all are fortunate because India is one of the major concentrations of C++ programmers. It is odd that there's not been, there hasn't been the same degree of organization as there's been in the past, but there's a lot of C++ programmers in India. If you look at the demographics from JetBrains, there's actually far more C++ programmers in India and like in Asia in general. There's just far more C++ programmers than there are in the rest of the world. I think there's the estimate is that there's 1.5 million C++ programmers in India, and there's 1 million in the US and Canada. Wow. So you have a ton of C++ programmers. So there should be a lot of people interested in C++.
Yes, truly.
Yeah. Moving to the next question, Hemil has one question. Which one do you prefer? Is stood expected or exceptions, and under what conditions?
It's actually, I've actually iterated between the two throughout my career. When I worked on HPX, which was a parallel runtime at the start of my career, we used exceptions because it was a parallel runtime. It was system software. It was an application code, and really exceptions were the only sane way to do things. And we had this crazy technology where we could take an exception that was on one node. We could take an entire trace of all the context of that node, and then we could serialize it and send it under the wire and deliver it to the head node and rethrow it there, and then tear down the entire distributed system. Except there was a 6-month period where sometimes the exception would get lost in transit and you wouldn't know that a error had occurred. But then I worked on HPC applications for a while, and particular applications on CPUs where vectorization was really important. And then I hated exceptions for a period of time because any no except code, any code that could potentially throw, would completely shut off the compiler vectorizer. So then I got very big on the whole exceptions are evil thing. And then I'm back again working at NVIDIA on parallel runtime systems essentially. And so now there are no exceptions on GPUs, so they don't interfere with our vectorizers. So it's less of a concern now. I mean, these days for a lot of our core libraries, we do use exceptions, and exceptions are a lot better than the C-style error codes that get used by a lot of our low-level APIs. And because I primarily deal with asynchronous systems, exceptions can be particularly good because an error code can be really confusing in an asynchronous environment because it might return an error that happened from a prior asynchronous operation, or the operation may have failed, but you may not know it yet. Whereas an exception, it at least cannot be ignored. which is the main value of an exception, that you can't accidentally drop it. Whereas with error codes, especially in asynchronous systems, you might forget to check an error code from one function because you didn't think that it could fail, but actually it could have been a prior thing that failed. Now, std_expected solves this problem because unlike an error code, you can't ignore a std_expected. If you get back a std_expected object and you do nothing with it and it contained an error, it will throw when you destroy it. Or it'll do some bad thing when you destroy it. I don't remember exactly what it is, but I believe that it does not let you ignore the error, which is its main value. Whereas with an error code, it's just some int, and if you ignore it, nothing bad happens. And that's my main problem with it, with error handling mechanisms that aren't exceptions, is that I want an error handling mechanism that does not silently ignore errors.
Yeah, so I hope this answers Emil. I hope you are satisfied with the answer. And so moving to the next question from Mayur. So he has questioned something which I think you all some part you may have addressed in the previous question related to C++ and Go and Rust thing. So he is asking that does C++ has a bright future? Seeing the popularity of newer languages which are relatively easier. So will C++ end up primarily used to support legacy code or few other areas, or is there any new something is coming?
Yeah, so I would say I think C++ has a bright future, and but for sort of a pessimistic reason, which is that I think that there's always some new cooler language. I think that's never not been the case. It used to be D. Who programs in D anymore? I think that some of these new languages will catch on, but it will take a very long time. Rust might have legs. I think like Rust, and I think Swift's the other interesting one. Like I don't think C++ is going anywhere, and I think C++ 20 was a huge major revision of the same size and scope as like C++ 11 in many ways. I think it will revitalize the language once we start to see the compiler support for it come out. And also the consolidation around CMake is a really big thing for the community. And I think we're going to see a similar consolidation around package management happening in the next few years. And, one of the strengths of C++ is the tooling. There is so many developer tools and solutions out there for C++. Not every other language has that. And I think that's just going to continue getting better. So I think that over the next 10 years, we're going to see a lot of growth and improvement in the C++ tooling ecosystem and the way that we structure projects, the way that our build systems work, the way that we manage dependencies. And I think that that's going to make the language a lot easier to use. And I think that's probably a good place for us to stop on an optimistic note, because it can sometimes be hard to find those with me.